When data moves from one place to another, like across the internet or over a Wi-Fi connection, it's called data in transit. That data needs protection, just like data on your hard drive. That's where transport encryption comes in. Here are the 3 common ways we protect data in transit. You have WPA. This secures traffic over wireless networks. Then you have your IPsec. These are your VPN tunnels between 2 endpoints over the internet. And you have TLS. This secures web traffic like HTTPS, email, and more. Instead of encrypting the actual data with the public key cryptography because that's slow, you guessed it, we use symmetric encryption for the heavy lifting. And we use asymmetric encryption for securely exchanging the key. Here's what the process looked like. Let's use Bobby and Brown. Let's say Bobby gets Brown public key, usually from his digital certificate. Well, Bobby encrypts the message with a symmetrical key called a session key. Bobby then encrypts that session with Brown's public key. The encrypted message and encrypted session key are sent to Brown. Brown then decrypts the session key using his private key. Brown then uses the session key to decrypt the message. This setup is called a digital envelope because it wraps the secret key securely. Transport encryption doesn't just hide the data, it also proves the data wasn't tampered with, integrity protection. That's where HMAC, hash-based message authentication codes, come in. And HMAC combines the session key with a hash of the message. If the message changes, the hash breaks, and the tampering is detected. Now, let's say a hacker records a web session today and somehow steals your private key in the future. Could they go back and decrypt that session? Yes, unless you're using password forward secrecy, PFS. PFS ensures that each session has its own ephemeral key that's used once and then discarded. Even if someone gets the server's private key later, they still can decrypt old sessions. PFS is implemented using something called the Diffie-Hellman ephemeral, DHE. With DHE, Bobby and Brown use public and private key values to derive a shared secret. A hacker can see the public value but still can't figure out the secret. Only Bobby and Brown can calculate the session key. This kind of key agreement protects old conversations even if the server is later compromised. It's why most secure systems use PFS today. Now let's talk about authenticated encryption. Some symmetric algorithms combine encryption with authentication automatically. They are called authenticated encryption modes, and they make sure data is both confidential and verified. Alright, now let's shift gear to blockchains. This is a decentralized and tamper-resistant way to store transactions. Here's how it works. A block contains transactional data, a timestamp, and a hash. Each block includes the hash of the previous block. This links all the blocks in the chain, hence the name. If you alter one block, it breaks the chain. That's how tampering is detected. The entire blockchain is stored on multiple systems in a peer-to-peer network. No single machine owns it. Everyone has equal access, and everyone can see the same version. Blockchain isn't just for cryptocurrency. It's used in financial systems, it's used in legal contracts, online voting, digital identity, IP protection. Because of its transparency and security, blockchain continues to gain traction across industries. Alright, that's it for now. Here's a recap. Transport encryption protects data in transit using WPA, IPsec, and TLS. Key exchange use asymmetric encryption to share a symmetric session key securely. A digital envelope wraps the session key with public key encryption. HMAC ensures data integrity and authenticity. Perfect forward secrecy, PFS, keeps past sessions safe even if private keys are stolen later. Authenticated encryption combines encryption and authentication in one step. And lastly, we learned that blockchain is a decentralized tamper-proof ledger used for crypto, contracts, voting, and digital identity. See you in the next one.